Whenever you make a lightning-fast online purchase, get an instant push notification on your phone, or see a live dashboard update, there's this highly efficient event-driven architecture working completely behind the scenes. At the heart of it, webhooks. In this explainer, we're going to break down exactly what webhooks are, why they're aggressively replacing older systems, and the step-by-step mechanics of how they actually work.
Section 1. The polling problem. Basically, why we need to stop asking and start receiving.
Okay, imagine you're waiting for a super important message, so you just sit there constantly refreshing your email inbox every 2 seconds. You click refresh. Nothing. Refresh again. Still nothing. That mind-numbing repetitive action, that is exactly how traditional API polling works. The early web was almost entirely poll-based. Your app repeatedly bugs the server asking, hey, anything new? How about now? Now? And most of the time, the server just gives a resounding no. You're wasting network requests, you're burning through computing power, and honestly, you're wasting time just to be told nothing happened. And the real-world consequences here can be catastrophic. Just picture a massive Black Friday sale. If millions of devices are polling a server all at once, they can literally crash the entire system.
So look at the stark difference between traditional polling, which is constantly asking, and webhooks, where you instantly receive. Imagine if instead of you furiously hitting refresh, your email provider just instantly tapped you on the shoulder the exact millisecond a new message arrived. You don't have to keep checking. You can just go about your day totally confident that the information will come to you the absolute second it's relevant. That's the fundamental difference here, and it is exactly how webhooks save incredible amounts of bandwidth and keep these massive systems perfectly stable.
Section 2. Webhooks, also known as the reverse API. Webhooks completely flip that traditional client-server relationship right on its head. Think of a webhook as a push-based communication tool. Instead of your app begging for info, the server takes charge. It automatically pushes data to your application, but only when a specific event actually happens. Take heavy hitters in the tech industry like Stripe, Shopify, or GitHub. The absolute second a payment succeeds, a customer buys a shirt, or a developer pushes new code, their servers reach out directly to yours. It's almost like having a VIP hotline.
Section 3. The event-driven flow. Let's look at the step-by-step mechanics.
All right, here's how the magic actually happens from start to finish. Step 1, you register a specific URL with the service you're using. This is what we call your webhook endpoint. Step 2, an event happens out there in the real world. Let's say a customer's payment successfully goes through. Step 3, the provider instantly bundles up that data, usually formatting it as a JSON payload, and shoots it directly to your registered endpoint using an HTTP POST request. And finally, step 4, your server receives that request and fires back an HTTP 200 OK response, basically just to say, got it.
Now listen up, because this is the golden rule of webhooks. Acknowledge immediately, process asynchronously. When your server gets that webhook, it needs to fire back that 200 OK response incredibly fast. The absolute most crucial thing here is that you do not try to do any heavy processing before sending that response. You have to acknowledge receipt right away and then take the actual data and do the heavy lifting in the background asynchronously. Why? Because these webhook providers are impatient. If they don't get that OK within a couple of seconds, they're going to assume the delivery failed and they will automatically try sending it again.
Which brings us right to Section 4, the duplication challenge, and dealing with retries.
Because those providers might aggressively resend the exact same event multiple times if they even suspect a delivery failed, your app has to be smart enough to safely ignore the duplicates. Enter a vital engineering concept, idempotency. I know, it's a big word, but it just means designing your system to safely handle the exact same thing twice without breaking. Each webhook usually comes with a unique event ID or an idempotency key. Before your app does anything, it checks, hey, have I already processed this exact ID? If yes, you simply acknowledge it and move on. Without idempotency, a single automatic retry could cause an absolute disaster. We're talking duplicate database entries, spamming a user with the same email, or total nightmare scenario, charging a customer's credit card twice for a single order. In modern system design, you literally have to build for at least once delivery, not exactly once delivery. Out in the Wild West of the internet, servers crash, traffic randomly spikes, and events show up completely out of order. Your own endpoint might be temporarily unavailable for a quick maintenance reboot or a random internet outage. Because of all this chaos, duplicate deliveries aren't just possible, they are completely normal. You have to just assume that events will hit your server multiple times and build your architecture to handle those duplicates safely.
Section 5, securing your webhooks. Let's talk about verifying the source.
Here's the scary part. Because your webhook endpoints are public URLs sitting out there on the internet,
Literally anyone could try to send you fake data. You can never, ever trust a payload blindly. So how do we fix this? With a cryptographic handshake. Professional providers protect their payloads using HMAC SHA-256 signatures. Basically, the provider generates a complex mathematical hash of the data using a secret key you both share, and sticks that signature in the HTTP header. When your server gets the request, it takes that exact same shared secret key and generates its own hash from the incoming payload. Then you just compare the two. If your server's signature matches the provider's, boom, you know it's authentic and untouched. If they don't match, no way. You reject that request immediately.
But wait, checking the signature is only half the battle here. You also absolutely have to validate timestamps to prevent what's called a replay attack. A replay attack is a massive security threat where a hacker captures a totally valid webhook request and maliciously fires it at your server later on. Because the payload itself hasn't changed, that HMAC signature we just talked about, it would technically still look perfectly valid. To stop this dead in its tracks, providers stamp their requests with the exact time they were sent. Your server just needs to check that timestamp and make sure it falls within a super tight acceptable time window. If the timestamp is too old, you drop the request completely.
Section 6, the takeaways. Let's review the rules for reliable webhooks.
All right, let's wrap this up. Here is exactly what you need to take away today. 1. Register your endpoints so the provider knows exactly where to push your data. 2. Never trust blind data. Verify every single incoming request using those HMAC SHA-256 signatures. 3. Fire back a 200 OK response instantly so the provider doesn't start spamming you with retries. 4. Take the heavy lifting offline and process your events asynchronously in the background. And number 5, always assume duplicate deliveries are going to happen. Use Idempotency to safely handle them and validate your timestamps to block those nasty replay attacks. Nailing these 5 rules is exactly what you need to confidently explain webhooks, and more importantly, to build rock-solid, enterprise-grade, event-driven systems.
So, the ultimate takeaway here is pretty simple. Stop polling. Stop wasting precious computing power asking servers if something new has happened, and start building systems that let the data come to you. The entire digital world is rapidly shifting to push-based architecture. So how will you implement event-driven architecture in your projects today? Thanks for joining me on this explainer.